Welcome to the Deep Dive. We're tackling a really big topic today, artificial intelligence.
It's definitely everywhere.
Yeah, it's moving incredibly fast, isn't it? It's showing up, way beyond just tech companies now. We're seeing it in healthcare, banking, retail, even manufacturing, like the Harvard Gazette pointed out recently.
Mm-hmm.
And with that speed, one thing becomes really, really clear. We absolutely have to figure out the security and the responsible side of AI.
Exactly. And for you, our listener, who's trying to grasp all this without getting totally overwhelmed, that's really our goal here today.
Right.
In this deep dive, we've sifted through quite a few expert reports and analyses. We're aiming to pull out the really crucial bits about AI security and, how we're trying to govern it. Think of it as your faster track to what actually matters.
Absolutely. We've got some really interesting stuff lined up, reports that dig into how we balance AI's potential with managing those risks. And before we jump in, we really want to thank the organizations supporting this deep dive. www.airriskassess.com. They're right at the forefront of evaluating AI risks.
Super important work.
Yeah. And also risk.quantumsecurity.ai, who are tackling the vital security challenges around quantum computing, another big emerging area.
Which has its own overlaps, potentially.
Definitely. And www.globalcompliancemap.com, helping organizations navigate that complex web of international rules and regulations.
All incredibly relevant to what we're discussing.
Exactly. The very challenges we're unpacking today. Their support makes this possible. Okay, let's get started.
Right. So let's first just touch on how much AI's role has expanded. That Harvard Gazette piece really highlighted its shift, from mostly science and research into everyday industries, healthcare, finance.
Big economic potential there, obviously.
Huge potential, yes. But, and this is the critical part, there's also the other side, the potential for harm. Because these AI systems, they can be incredibly complex, sometimes kind of like black boxes.
Right. Even the developers don't always fully get how they arrive at a decision.
Precisely. And that naturally raises concerns about, unintended societal impacts.
And the Harvard Gazette piece really hit on a key point there that, in the U.S. at least, we don't really have a complete overarching framework for oversight yet.
Yeah, it's lagging behind the tech.
It feels a bit like we've built this incredibly powerful engine, but we're still sort of figuring out the roads and the traffic signals for it, which leads us right into, okay, how do we actually keep these systems secure?
Exactly. And a good place to look is this report from CISO, the Cybersecurity and Infrastructure Security Agency. They have a guide specifically on autonomous ground vehicle security.
Self-driving cars, basically.
AVs. Yes. AVs, they're poised to completely change transportation, but that change brings a whole host of new security questions. CISO even has this useful graphic showing the main parts. You've got the operation and communication system.
Like GPS talking to infrastructure.
Yeah, exactly. And then you've got the sensor systems, the LiDAR, radar, cameras, the things that let it see the world, all connected.
And that's where the risks really come in, right?
Yeah.
CISA spells out some specific dangers.
They do. At the sort of enterprise or business level, they talk about supply chain vulnerabilities.
Okay, like a compromised part from a supplier.
Exactly. Imagine a bad actor tampering with a component before it even gets installed. That could affect thousands of vehicles.
Wow.
And then at the level of the individual car, the asset level, they bring up things like AV ramming attacks.
Where someone could potentially hijack it remotely.
That's the concern, yeah. Using the vehicle itself as a weapon. It really paints a stark picture of the stakes involved.
It really does. So the answer isn't just one single fix.
No, absolutely not. CISA really stresses this need for a multi-layered security approach. It's about ongoing threat analysis.
Yeah.
They mention their AVCAT framework for that. And leveraging resources from places like NIST, the National Institute of Standards and Technology, and Auto ISAC, which focuses on sharing cyber threat info within the auto industry.
Collaboration seems key.
It is. And then there's specific things for the vehicles themselves, regular cybersecurity testing, keeping software updated.
Like we do with our phones and computers.
Exactly the same principle. Those updates often patch critical security holes.
Makes sense. And this isn't just about cars, is it? There's a paper from Cal State Fullerton looking at unmanned autonomous systems, UASs.
Right, UASs. That broadens the scope considerably. We're talking drones in the air, robots on the ground, even autonomous systems underwater.
Much wider range.
And the core issue, as that paper points out, is their reliance on cyber systems to operate. They're collecting data, processing it, making decisions based on it. And that data is often valuable.
Making them attractive targets.
Absolutely. It's not just about the physical machine. It's about protecting its digital brain and the information it handles.
So for these UAS, what are the key security goals? What do we need to protect?
Well, the Cal State Fullerton paper breaks it down into 5 core security attributes. You might recognize these from general cybersecurity: confidentiality, integrity, availability, authentication, and authorization.
Okay, let's unpack those quickly for UAS. Confidentiality.
Keeping sensitive data private. So, for a drone, making sure only authorized users can see its video feed, for example, preventing eavesdropping.
Got it. Integrity.
Ensuring the data is accurate and hasn't been tampered with. You need to trust the sensor readings, the navigation data. Corrupted data could lead to disastrous decisions.
Right. Availability.
Making sure the system and its data are accessible when needed. Can the drone communicate with its operator? Can the ground control system function?
Authentication.
Verifying identity. Is it really the authorized pilot sending commands? Or is it someone spoofing their signal?
And authorization.
Controlling permissions. Okay, you're authenticated, but what are you allowed to do? Maybe a technician can update software but isn't authorized to actually fly the drone.
Okay, those 5 make sense. And I assume each one faces specific threats in the UAS context.
Exactly. For confidentiality, the paper mentions risks like weak access controls internally, but also external threats like data sniffing over wireless links, exploiting encryption weaknesses, or even Wi-Fi disassociation attacks that kick a drone off its network.
Tricky stuff. What about integrity?
Big ones. There are man-in-the-middle attacks, someone intercepting and maybe altering communications. Also, just ensuring the data's origin is authentic. And like we said, the consequences of corrupted data, especially for control, are huge.
And availability.
That could be hit by things like jamming the communication signals, distributed denial of service DDoS attacks, flooding the ground control systems, or even injecting malware onto the UAS itself.
That's quite a list of potential ways things can go wrong. How do organizations even start to tackle this?
It starts with threat modeling and risk analysis. Basically, systematically thinking through what could go wrong, how likely is it, how bad would it be?
Prioritizing the biggest dangers.
Right. Tools like CVSS, the Common Vulnerability Scoring System, can help put numbers on those risks. The paper also talks about building defense in depth, multiple layers. Things like using honey nets, which are decoy systems to lure attackers.
Oh, interesting.
Yeah, and intrusion detection and prevention systems to spot and block attacks as they happen. It's about making it much harder for an attacker to succeed.
Okay, so we've covered security for these physical autonomous systems, cars, drones. Let's shift gears now to generative AI. The AWS white paper on its security landscape caught my eye.
Yeah, generative AI it's a whole different ballgame in some ways. Its power to create content, text, images, code is amazing, but it also brings completely new security challenges to the table.
It's not just amplifying old risks.
It does that too, but it also introduces entirely new attack vectors. Things like context window overflow and prompt injection are prime examples.
Okay, context window overflow and prompt injection. Can you break those down a bit? They sound technical.
Sure. So think of the context window as the AI's sort of short-term memory for the current conversation or task.
Okay.
If an attacker manages to flood that window with excessive information, maybe hiding malicious instructions within it, the AI might get confused, forget earlier safety instructions, or even leak sensitive data that got pushed into that oversized context.
I see. Overloading its working memory.
Kind of, yeah. Prompt injection is maybe more direct. It's where an attacker crafts a clever input, a prompt designed to trick the AI into ignoring its original instructions and doing something else.
Like what?
Like revealing confidential training data, executing harmful code, or generating inappropriate content. It's essentially sneaking commands past the AI's defenses within what looks like a normal request.
That sounds incredibly subtle.
Yeah.
And dangerous. How do you defend against that?
Well, the AWS paper really emphasizes needing a more agile, proactive security approach. You can't just bolt security on at the end. It needs to be part of the development process itself, involving the data science teams. They call it shifting security left.
Building it in from the start.
Exactly. Traditional network, perimeter security, firewalls and such, they're not really sufficient for these kinds of AI-specific threats. We need new, innovative measures designed for AI. Threat modeling also has to consider the AI's own agency, the fact that it can act based on the inputs it receives.
Right. So what are some specific defenses for, say, context window overflow?
Strategies include things like carefully managing input length, sanitizing inputs, and maybe using secondary AI classifiers to screen prompts for malicious content before they hit the main model. Defense in depth again.
And for prompt injection, especially those tricky indirect ones.
That gets complex. It involves things like establishing clear trust boundaries, not implicitly trusting all data sources the AI might access, classifying data by sensitivity, securing the APIs the AI uses to fetch external information, and just good overall data hygiene are all crucial, basically limiting the pathways for malicious influence.
The paper also mentioned reliability risks with these large language models, LLMs, right, making them more resilient.
Yes, absolutely. Even without attacks, LLMs can sometimes hallucinate or generate incorrect information. So, resilient strategies are important. Things like using a modular architecture so one faulty component doesn't crash everything,
Okay.
and implementing validation layers, checks, and balances to assess the plausibility or consistency of the AI's output before it's shown to a user. Plus, the basics. Minimizing data leaks from AI agents that might have too much access, anonymizing logs carefully, and using secure caching.
It's clear that the technical security side is a huge ongoing challenge. Let's broaden out again to the ethical side and governance. How do we make sure AI is used responsibly?
That's the other massive piece of the puzzle. As AI takes on more decision-making roles, the ethical questions loom larger, as the Harvard Gazette also discussed. Concerns about bias baked into systems, fairness, transparency, there's a lot.
And a feeling that regulation needs to catch up.
Definitely. The Cloud Security Alliance, CSA, offers some useful perspectives here on AI governance for ethical use. They differentiate between types of AI, like discriminative AI, which is good for classification, versus generative AI, which creates new stuff.
And regulators are starting to notice generative AI specifically.
They are. Because it's so versatile, it's often being classified as general-purpose AI, or a foundation model. And that label matters because it could trigger specific, maybe stricter regulatory requirements down the line.
Which brings us to the global regulatory landscape. The EY report you mentioned highlighted a trend there.
Yeah, the trend seems to be towards risk-based approaches. Instead of one-size-fits-all rules, regulators in different regions are looking at tailoring requirements based on the potential risk level of a specific AI application. High-risk applications, like in healthcare or critical infrastructure, would face more scrutiny.
Makes sense.
And the EY report also notes how AI regulation is forcing a rethink of adjacent policy areas, data privacy rules, cybersecurity standards, even rules around digital content flows. It's all connected.
But it's not just government setting rules, right? Companies have a big role.
A huge role. The EY report stresses how vital it is for companies using or building AI to have their own strong risk management frameworks. That means clear governance structures, maybe internal ethics boards or committees, and crucially, mechanisms for accountability and explainability.
Understanding why the AI made a certain decision.
Exactly. And Atlassian's perspective on responsible AI echoes this, focusing on core principles like fairness, privacy, transparency, and accountability.
Are there practical ways companies can implement those principles?
Atlassian suggests things like building diverse development teams to reduce bias, providing ethics training for engineers and data scientists, and trying, though, it's hard to actually measure the ethical performance of AI systems.
Measuring ethics. That sounds challenging.
It really is. But the intent is important, and this ties into frameworks like the NIST AI Risk Management Framework, the AI RMF, which a Carnegie Mellon paper discussed.
Right. The NIST framework? How does that help?
It gives organizations a structured process. It has these 4 core functions. Govern setting up the risk culture, map identifying the specific risks, measure assessing those risks, and manage taking action to mitigate them. It's a life cycle approach.
Is it actually being used?
Yeah, the Carnegie Mellon paper gave examples that's being applied in sectors like human service, even the hotel industry. So it's not just theoretical. It's proving useful in practice.
What about that challenge of using off-the-shelf AI, the black box problem?
That's a really thorny issue raised in the CMU paper. If you buy an AI product and don't know exactly how it works internally, how do you manage its risks responsibly?
Good question.
The suggestion is that procurement processes need to evolve. Companies need to demand transparency and evidence of responsible development and risk management from their AI vendors. They mentioned the Department of Defense's vetting process as a possible model.
Interesting. And we're seeing more legislative action, too.
Definitely. The IAPP, that's the International Association of Privacy Professionals, tracks U.S. state legislation. And their tracker shows a real uptick in states proposing or passing laws specifically aimed at governing AI use in the private sector. The landscape is definitely heating up.
Okay, one last area to touch on, based on our sources, some fundamental security principles specifically for machine learning itself.
Right. This drills down into the specifics of ML security. The core message is, Understand ML's unique vulnerabilities and bake security into the ML workflow from day one.
What's an example of an ML-specific principle?
One key idea is about minimizing an adversary's knowledge. You need to balance sharing information for research progress with protecting system details that could help an attacker launch things like transfer attacks, where they train their own model to mimic and then attack yours. It's a tricky balance.
What else is crucial?
Really understanding ML-specific attacks and defenses is vital. Reviewing the security impact throughout the entire development lifecycle. Securing your supply chain not just for code, but critically for the data and pre-trained models you might use. Where did they come from? Can you trust them? Are there validation processes?
So provenance and validation are key.
Absolutely. And tracking your assets, the models, the data sets throughout their life cycle. Version control metadata, knowing what you have and where it came from. Also, designing for security, keeping the model architecture appropriate, not overly complex for the task, and really trying to understand its behavior.
And security doesn't stop at development, right? What about deployment?
No, deployment has its own considerations, things like rate-limiting model outputs, maybe sanitizing outputs, and definitely monitoring user queries for weird or anomalous behavior that might indicate an attack attempt.
What about models that keep learning over time? Continual learning.
That adds another layer of complexity. You need robust validation every time the model updates itself from new data to make sure it hasn't learned something harmful or developed a new vulnerability. Tracking those updates is critical too.
So wrapping this all up, what's the big takeaway for you, the listener? It feels like navigating AI requires this really broad understanding now.
It really does. As we've kind of walked through, you need to grasp the security vulnerabilities, which are evolving constantly, especially with things like generative AI. You need to grapple with the ethical questions, fairness, bias, transparency, and you need to be aware of the governance frameworks and regulations that are trying to shape its responsible use.
It's definitely not just a tech issue anymore. It touches everything.
Exactly. And the information we've drawn from these different sources, government, industry, academia, hopefully gives you a solid foundation to stay informed as things keep changing so rapidly. It's clear that security, ethics, governance, they're all deeply interconnected.
And we should also acknowledge the role of organizations like our sponsors, www.ariskassist.com, risk.quantumsecurity.ai, and www.globalcompliancemap.com. They are actively working on these very problems, assessment, security, compliance, which are essential for building that trustworthy AI ecosystem we need.
Their work is fundamental, yeah.
Absolutely. So as AI weaves itself more and more into the fabric of our lives, shaping industries, influencing decisions, it really falls on all of us, individuals and organizations, to think proactively about how we build a future where AI is, well, both incredibly powerful and fundamentally trustworthy.
Which leads us to maybe a final thought to leave you with. As AI continues this deep integration into society, how can we, collectively and individually, ensure its immense power is harnessed in a way that's truly beneficial and secure for everyone involved?
A really important question to keep thinking about. And once again, our sincere thanks to our sponsors, www.ariskassist.com, risk.quantumsecurity.ai, and www.globalcompliancemap.com. Their commitment to these vital areas made this deep dive possible for you.